In this video, you will learn about compound formation and the octet rule. Bohr's model can be very useful in predicting and understanding of chemical composition of many compounds. For example, it can be used to determine why chemical formula of sodium chloride is like this, NaCl, and why it is not Na2Cl or NaCl2 or any other variation. The rule that helps us understand this composition is called octet rule or rule of 8. This rule came from the observation of unique nature of elements in group 8A. Elements in group 8A are called noble gases. Noble gases are least reactive of all known elements and are exceptionally stable. All of these elements in group 8A have 8 electrons in their valence or outermost shell. And you can see this from this electron filling diagram. You can pause this video to familiarize yourself with this electron filling of noble gases and see that there are 8 electrons in the valence shell of all these noble gases. Helium is the only one noble gas that does not have 8 electrons in its outermost shell but have only 2 electrons. Even with 2 electrons, helium has a full outer energy level, and because it is the only energy level that helium have, and it can hold maximum of 2 electrons, and full outer energy level is the most stable arrangement of the electron. So helium is also stable, similar to rest of the gases in the noble gas group. It was interpreted that noble gases are unreactive because of their electron configuration or because of having 8 electrons in their valence shell. American chemist Gilbert Lewis used this observation to explain the types of ions and molecules that are formed by other elements, and he called this explanation the octet rule. And according to octet rule, elements react to form compounds in such a way as to put 8 electrons in their outermost valence shell by giving them valence shell configuration identical to that of noble gases and making them exceptionally stable. Let's use octet rule for sodium and chlorine to understand why the chemical formula for sodium chloride is NaCl and not any other variation. Sodium is from group 1A with 1 valence electron, and chlorine is from group 7A with 7 valence electron. To understand how these atoms react, focus on the valence shell configuration of sodium and chloride and apply octet rule by asking how can sodium and chlorine atom can get 8 electrons in their valence shell. The options available for sodium are either to gain 7 electrons and have the noble gas configuration of argon. After gaining 7 electrons, so sodium is 11 right now. After gaining 7 electrons, sodium will have 18 electrons and will be argon electron configuration. The other option that sodium have is to lose 1 electron and have noble gas configuration of neon. So from 11, when sodium loses 1 electron, its noble gas configuration will be similar to neon. So sodium have 2 options. Similarly, chlorine have 2 options as well. Chlorine can either gain 1 electron and become the noble gas similar to argon after gaining 1 electron, or chlorine can lose 7 electrons and become the noble gas similar to neon. So 2 options available for both sodium and chlorine, but the best option for sodium is to lose 1 electron instead of gaining 7 electrons. So sodium will lose 1 electron, and the best option for chlorine is to gain 1 electron and have the noble gas configuration of are gone. So after losing one electron, sodium will have one more proton than electron in its outermost shell, and this will result into a positive one charge, and this is called as sodium cation. Whereas after gaining one electron, chlorine will have one more electron, and there will be negative one charge on the chlorine atom, and it is called as chloride anion. We can now also explain why the composition of sodium chloride is NaCl and it is not NaCl2 or any other composition, is because each sodium atom is losing one electron and each chlorine atom is picking up that one electron. So in order to maintain this balance of exchange of electrons, these elements must combine in 1-to-1 ratio. From this example, you can also notice that in this exchange, the atom that loses electron, sodium, it is a metal, and the atom that is gaining electron is a non-metal. This is actually a typical behavior of metals and non-metals. All these pale yellow elements are metals, and metals will lose electron, and non-metals are the one that will gain electrons. So this will lead us to the chemical behavior of metals and non-metals. A metal is an element that tends to lose its valence electron and become a cation in the process. A non-metal is an element that tends to gain electron and become an anion in the process. Now let's look at these elements in the periodic table. So we have metal, group 1A is all elements are metals except hydrogen, and all of these elements have one valence electron. So with one valence electron, and metals tends to lose electron, so when the metal will lose one valence electron, the charge on this group will be +1. All the elements, including hydrogen, behave same. Hydrogen will lose electron instead of gaining electron. So including hydrogen, all elements in this group will lose electron and the charge on this group will be +1. Group 2A element, they have two valence electrons, and when they lose those two valence electrons, the charge on this group will be +2. You don't have to make the atomic structure that you saw in the previous slide here for sodium chloride in order to determine how these elements behave in a chemical reaction. You can predict that behavior just by looking at their valence shell electron composition. So with two valence electrons, these elements will lose two electrons and the charge on these elements will be +2. Elements in group 3 from aluminum, they have three valence electrons, and when they lose their three valence electron, the charge on this group will be +3. Notice that I didn't write any charge for group 4A. They have four valence electrons, and they behave different. They don't lose electron and they don't gain electron. We will see in the next chapter how elements in group 4A behave. But for now, let's move to the next group. So group 5A have five valence electrons. And for this group, it is easy to gain three electrons to get the noble gas configuration rather than lose five electrons and become the noble gas that is before these elements. So group 5A will gain three electron, and after gaining three electron, the charge on the group 5A will be -3 because three more electrons will bring -3 charge. Group 6A have six valence electron, need two more electron to get the noble gas configuration, will gain two electron, and the charge on the group will be -2. Group 7A have seven valence electron, need only one electron to get the noble gas configuration, and after gaining that one electron, the charge on the group will be -1. So you need to kind of memorize these charges or understand how the elements in each group will behave and what will be the charge on these groups. So group 1A will have positive 1 charge, group 2A will have positive 2 charge, group 3A positive 3, group 5A negative 3, group 6A negative 2, and group 7A will have negative 1 charge. You can pause this video to absorb how we have charges on these groups before you move to the next slide. Let's see how to predict the formula of a compound formed from the reaction of two elements. Step one for this is to write elemental symbols of both elements, then identify which element is metal and which element is non-metal. And that you can identify from the periodic table. Elements on the left-hand side are metals, and elements on the right-hand side are non-metals, and you have to identify the regions where they are. Next step is to determine the number of electrons the metal will lose. That you can also determine with the help of valence electrons that a group can have, and how that group will behave to get the octet or noble gas configuration. So metals will lose electron to get the noble gas configuration, and the number of electrons that a metal will lose equals to the valence electron that they have. So from that you can write the symbol of the cation that will form from that element. Next you will determine the number of electrons for the non-metal and determine the symbol for the anion. Next, you will write the cation and anion symbols next to each other. Always the cation will be first and anion will be next in that formula. The last step will be you will be doing crisscross the values of charges, leaving out the positive and negative sign. So let's do some practice and these steps will be clear when we will do that. So in this example, we have to predict the chemical formula of a compound that results from the reaction between sodium and oxygen. You can pause this video, write the formula at your own, and then play the video to check your answer. So remember, the first step is we need to know the element symbols. So we already have the element symbols. And the next step is we have to find what type of ion they will make, cation or anion, and what will be the symbol for the cation and anion. So sodium is from group 1A, and sodium have one valence electron, and metals tend to lose electron. So when sodium will lose its one electron, the charge on the sodium is going to be positive 1. So we will write the symbol for sodium cation as Na positive 1. For oxygen, oxygen is from group 8A, have 6 valence electrons because it is from 6 group, right? So with 6 valence electron, to get the noble gas configuration, oxygen need 2 more electrons. And when this oxygen will gain 2 more electrons, the charge on the oxygen will be negative 2. So the anion that this oxygen will make will be Na. So sodium will make Na positive 1 and oxygen will make Na negative 2. The last step is you have to do crisscross of the charges. Charges are these numbers 1 and 2. So you are going to move these numbers at the subscript of these element symbols, and you will leave these signs. So negative sign and positive sign, we are not going to do anything with these signs. Okay, so just move the number. So when we move number 2 from here to here, you have Na2, and oxygen you have 1 here. And if we have one atom of any element, we just don't write 1. So your final formula going to be Na2O. And that is how we write a formula between two elements. Let's write down the chemical formula between aluminum and oxygen. And again, symbols are given, so we just have to find what type of cation they will make. You can pause the video, write the formula at your own, and then play the video to check your answer. Aluminum is from group 3A, have 3 valence electron. Metals lose valence electron and make cation. So aluminum will lose 3 valence electron, will become aluminum plus 3. Okay, and oxygen is from group 8A with 6 valence electrons, will gain 2 electron and become -2 anion. And then we are going to do the crisscross of these numbers, right? We will move these numbers here at the subscript, and we will leave the charges positive and negative. We are not going to do anything with that. So when we move this number here, we have Al2O3. So this will be the formula between aluminum and oxygen. Next, we have a formula between calcium and oxygen. You can pause the video, write the formula at your own, and then play the video to check your answer. Calcium is from group 2A. Group 2A is metal. Metals will lose electron. After losing electron, calcium will be +2. Oxygen is from group 8A. Have 6 valence electron, will gain 2 electron to get noble gas configuration. After gaining 2 electron, the charge will be -2. So, and once you do the crisscross, you will have 2 calcium here and 2 oxygen atom here. When you have same number of atoms for each element, we simply cancel them, and there will be a ratio between calcium and oxygen will be 1:1. Let's do one more example. Magnesium is metal, will lose its 2 valence electron, will make +2 charge. So magnesium is +2. Chloride is from group 7 and will gain 1 electron and become -1 anion. Next step, we are going to do crisscross. And when we do the crisscross, we will have magnesium, chloride. The charge for magnesium will go here at the subscript.